Welcome to the Littelfuse liftgate battery charger demonstration video. At this point, the liftgate battery charger is turned off because the engine is off, and the liftgate charger is in wait mode. The tractor batteries are at 12 volts. The voltage in the input of the battery charger is also at 12 volts. The battery charger is off, and the trailer batteries are also at 12 volts. Turning the engine on, the liftgate battery charger recognizes the current input, and the output current increases to the maximum possible as long as the voltage at the input does not get lower than 10 volts. In this case, we have the tractor trailer connection resistance is minimal. We're utilizing a 2-gauge wire, and the engine is on. If we add resistance, the input voltage will become lower. The charge output current remains the same. Now the input voltage is at 11.5 volts. In this condition, there is additional resistance at the 7-way connection that has been induced into the circuit, causing additional voltage drop to the input of the charger. The liftgate battery charger has a run extender feature. The run extender feature is turned on at this point, turning off the engine, but the battery reduces the battery voltage to below 13 volts, and the run extender feature will continue running until the battery voltage goes below 12.4 volts. In this case, you'll see that the 35 amp charger now sees 10 volts and adjusts automatically to not draw any more current than 22 amps in this condition at 10 volts. In the run extender mode, every 2 minutes the liftgate battery charger will turn off current and check the input battery to determine whether it should continue running. For this demonstration, the device checked the input current, turned off, and now has turned itself into its off mode, 0 amps, and the input voltage is equal to the output voltage. The liftgate battery charger also operates. We're going to demonstrate now, instead of with 2-gauge wire, if we had additional resistance with 4-gauge wire in the trailer between the front of the trailer and the box where the liftgate battery charger is connected. If we turn the engine on, we'll see the DC amperage continue to increase as voltage decreases up to the maximum 35 amp rating of the liftgate battery charger, and the input voltage did not approach 10 volts, which allowed the liftgate battery charger to achieve full voltage. Again, increasing the resistance, the induced resistance between the connection for mimicking corrosion or mimicking any other additional resistance, you'll notice that the DC voltage is reduced but doesn't approach 10 volts in this test sequence, and the battery charger continues to output 35 amps. In all conditions that we've demonstrated, the trailer batteries are receiving bulk voltage for this model, while the liftgate battery charger offers 3-stage battery charging. In this demonstration, the bulk mode battery charging is the only mode that is being utilized. The liftgate battery charger is also compatible with 7-way connections. As we change the liftgate battery charger to 7-way connection, you'll notice that the input voltage is reduced significantly because of the additional resistance of the 7-way connection and typical higher, smaller wires between the nose of the trailer and the liftgate system. We're assuming 12-gauge wire back and forth on both sides of that equation. The charger output current for the 35 amp device now is reduced to 15 amps, but the input voltage at the back of the system voltage at the back of the trailer maintains itself at 10 volts. This will leave the back of the trailer in a safe condition for an ABS system or any other brake systems that require sufficient voltage and power from the system. If additional braking were to draw further current from the 7-way connector, the liftgate battery charger would further reduce current in order to make sure that the input voltage was at 10 volts and that the liftgate battery charger was not causing the voltage to be reduced. In this condition, again, when we turn the engine off, we will see further reduction in DC amperage to 7 amps because the input voltage has been reduced when the engine was turned off. And again, in this condition, after 2 minutes, the liftgate battery charger will turn off momentarily to pull the input voltage, and will determine that the input voltage is not above 12.4 volts, and then will shut off to ensure a safe condition where the liftgate battery charger is not draining the batteries of the tractor. Through this mechanism, the liftgate battery charger is able to optimize charging continuously throughout the tractor's on-off cycle, as well as any braking cycles that occur during the transportation of the trailer with the tractor. After the liftgate battery charger has turned off into its sleep mode, you'll notice that the light is flashing a pulse indicating that it is now in standby mode, waiting for the tractor to be turned on. Turning on the tractor, again the liftgate charger will increase its current until the input voltage is reduced to its minimum level of 10 volts. Other features of the product that are not currently in this demonstration include the external temperature sensor wire that exits the liftgate battery charger and is connected to the trailer batteries. This ensures proper temperature compensation for charging levels. Charger output voltage will depend not only on 3-stage charging, bulk, absorption, and float, but also on temperature of the battery to post terminals. This concludes the liftgate battery charger demonstration.